Section 6.8, inverse variation. An inverse variation is a situation in which one quantity increases while another quantity decreases. Speed and travel time for a given distance is an example. For example, if you're traveling from city A to B and normally at 55 miles per hour, the trip takes 15 minutes. But should you increase the speed to, say, 70 miles per hour, what would be the time? And common sense would tell you the faster you go for that given distance, the time is going to decrease. That's an example of an inverse variation. And what you see here is the definition for an inverse variation. When a situation is modeled by a rational function of the form f of x is equal to k over x, or simply y equals k over x, where k is a non-zero constant, we say that there is an inverse variation, that y varies inversely as x, or that y is inversely proportional to x. The number k is called the variation constant or the constant of proportionality. And we can solve an inverse variation by the following formula for the pairs that follow an inverse variation. The product of the two pairs from one pair is equal to the product of the other two pairs. And let's take a look at an example of an inverse variation. This is a generic one. If y varies inversely as x and y is 2 when x is 64, find y when x is 4. So if we translate the relationship, they're telling us that y varies inversely, which means that that silent constant of proportionality or variation is in the numerator, and inverse, anything following inverse, is going to go in the denominator. So this is our generic relationship. They are giving us a complete pair here. Y is 2 when x is 64, which means we would have two of the three unknowns, which would allow us to solve for that third unknown to complete our inverse variation relationship here. Y is 2 when x is 64 gives us the following. Solving this equation, we'll multiply both sides by 64 to get k by itself. 64 times 2 gives us 128 is equal to k. That allows us, as I said, to complete our inverse variation here. It is y is equal to 128 over x, which allows us then to come up with the final solution to the problem. Find y when x is 4. Now we have only one unknown because we know that constant. X is 4. What will y be? Replacing x with the value 4, doing the indicated division of 128 divided by 4 is leaving us with a 32. That is one method, and if the problem does ask you for the constant of proportionality or variation, this would be the approach. If we're simply interested in the answer, we could use the relationship for inverse variation of those pairs by using the formula x1 times y1 is equal to x2 times y2. We have one pair, we'll treat those as our first, and here's our incomplete pair, we'll treat those as our subscripted variables with 2. So x1 would be 64 times y1, which is 2, is equal to x2, we're treating that as 4, and we're looking for the y sub 2. That's our incomplete pair in this inverse variation relationship. Simplifying 64 times 2, 128, looks familiar from the other approach to solving this. And solving for y, we'll divide both sides by 4. 128 divided by 4 is going to give us a 32 for the value of y and the solution to the problem.